Hey Algebra 1, we're going to do some more solving radicals today for this video, but we're also going to be using Desmos. So in a minute here, you're going to need to open up Desmos, but first we're just going to do a few warm-up problems here. So I'm going to go pretty quickly through these. If you need to pause or rewind, go ahead and do that. So first, let's look at number 1 here. We're going to add 4 to both sides. And then we will have square root of 2x plus 4 equals 4. And now I'm going to square both sides. So I get square root of 2x plus 4 squared equals 4 squared, which leaves me with the left side, the square and the square root cancel out. So that's 2x plus 4 equals 16. And now I can just solve this like normal. Subtract 4 from both sides gives me 2x equals 12. Divide by 2 gives me x equals 6. We should check our answers. So let's see, check. We have square root of 2 times 6 plus 4 minus 4 equals 0. That's going to give me 16 in the square root minus 4 equals 0. 4 minus 4 equals 0. That's correct. So we know my answer is good. For number 2, here I've got to subtract 8 first. And we get 3 root x minus 5 equals 3. And then I divide by 3. We get square root of x minus 5 equals 1. And now I square both sides. And that gives me x minus 5 equals 1, because 1 squared is 1. So my answer is going to be x equals 6 again. And let's check it. 3 root 6 minus 5 plus 8, does that equal 11? That'd be 3 root 1 plus 8 equals 11. That's 3 plus 8, which is 11. So we're happy. So there's my x equals 6. For number 3, here I have a square root on both sides, so I can square both sides right away, and that just cancels the square roots out. So this turns into 7x plus 1 equals 5x plus 6. Get your x's together. I'll subtract 5x. I get 2x plus 1 equals 6, and then I'll subtract 1, and we get 2x equals 5. So x equals 5 over 2. To check this one, we get, square root of 7 times 5 halves plus 1 equal to square root of 5 times 5 halves plus 6. Well, let's see, that's 35 over 2 plus 2 over 2. Get a common denominator there. Equals 25 over 2 plus 12 over 2. And both of those equal 37 over 2 square root. So we're good. And finally, number 4. Here I have to subtract 7. Square root of 12x equals negative 6. And right away, I see I have square root equals negative, so I've got to say no solution. You can't have that. All right, so what we want to do now is get to Desmos.com. So maybe you want to open up another tab, or maybe you want to use it on your phone. You can do that. But basically, we're going to solve these square root equations using Desmos. And so there's going to be 2 ways, and you can see them on the screen here. 2 methods. You can either find the zeros, which means we're going to be, the key is you're going to set the equation equal to 0. And then we basically find the x-intercepts. Or method 2 is just to find an intersection. So in method 2, we graph both sides and look for where they cross. So I'll do a little bit, or a couple of each, just to give you a sense of that. So example 1a here, let's try method 1. That's the highlighter. Let's try method 1. Okay, so method 1 says set equation equal to 0. So I'm going to go square root of x over 2 minus 3 subtract a half equals 0. I minused a half from both sides. And then we're going to type the equation in row 1, except when we do that, we don't put the equals 0, we do y equals. So on Desmos here, I'm going to type the equation in, y equals square root of x over 2 minus 3 and minus 1/2. And I double check, does that match up with what it's supposed to? It does. The y equals is replacing the 0. And so then it says to look for the x-intercept. So you see that gray point that popped up? I can click on it, and now I see that my x-intercept is 6.5 comma 0. And that means my answer is x equals 6.5. I'm solving an equation for x, so I'm not going to be right. I don't care about the y coordinate. I'm solving for x, so I need x equals 6.5. Now, let's do b here, and we're going to go with method 2 for b. Method 2 says I'm going to type the left side into row 1 and the right side into row 2. Okay, and what we want to do is we make sure we say y equals for both of them. And by doing this, I'm basically graphing the left side and I'm graphing the right side, and I want to see where they cross. So I go back into Desmos here, I clear off my first equation, and so the left side is square root of negative x plus 5, and the right side is 2. So I forgot the y equals, so I'll go back in front, put y equals. You don't need it for that one, but you do need it for this right side. When it's just a number, you have to have y equals. So we're going to go y equals 2. And then we can see that those two lines are equal to each other where they cross, which is not that point, that one, 1 comma 2. So my answer is the x coordinate. Well, the x coordinate is 1, so I say x equals 1 is my answer. All right, just do a couple more real quick. I tend to like method 2 better personally, because I don't have to manipulate the equation at all. So I can go right away for problem C and call both sides y equals. So let's go over here to Desmos one more time, and we'll do y equals square root of 6x minus 8 and y equals x. Right. Now when I look at that graph, the black line for y equals x does cross that, so you can zoom in here. It crosses it twice, so I'm going to click there and there. I get two answers. I get x equals 2 and x equals 4. Right? Remember, we only care about the x answer. So what I want you to do is take a minute, pause the video here, and try problems D and E, and then compare your answers with what I get in a second. All right, how'd you do? In D, you should get negative 0.3 repeating, or you could call that negative 1/3. And in E, we get x equals 0.24. You can see my graph over here right now. Be careful when you type in the first part of that the -1 is outside the square root. And just a quick thought, hypothetical here. What if we actually ended up with a picture that looked like this? Or let's not that high, like +5, where the graphs don't intersect. The answer would be no solution, because they never intersect. So look out for that as well. Thanks for watching.